So last lesson you should recall that we went through and discovered Pythagoras Theorem, which was c squared equals a squared plus b squared. I want you just to practice some of that rearranging to make A the subject in this particular theorem or in this particular formula. So in other words, rearrange it to get A equals. How would we do that? I'll give you about 30 seconds quickly. So step 1, c squared, what do we have to do? What's in the way of the a? The b squared. So we've got to take b squared. And then what's the next step? Elsie? Yeah, so undo the square by writing the square root. Now, this may or may not be familiar to you. It was in one of the other equations in that rearranging sheet we did. Or if you prefer, a equals the square root of c squared plus take b squared. So there's a take involved. Remember, c represents the hypotenuse and b is another short side. And a is the second short side in the triangle. So that's also a short side. So by rearranging that formula, it now gives us a new formula for the side length of a triangle that's not the hypotenuse. And it's got to be a right angled triangle, of course. So you can choose to use this formula. My preference is not actually. My preference is just to rearrange it as you go, and I'll show you how to do that in the first example. But you can, if you have a really good memory and can memorise and remember these formulae, you can actually use that. It will still give you the same result. But what I prefer, because most people will remember Pythagoras Theorem but forget everything else. So what I prefer is to say, right, well, in a situation like this where I've got 3 sides and I know I'm trying to find the shorter side, let's put in what we know. So I know that Pythagoras' theorem, and this is why I always say write the rule, is a squared plus b squared equals c squared. So I've purposely written it the other way around because I know some people really like the variable on the left. And then put in what we know. So we know that c is the hypotenuse. And so of course it shouldn't be 6, it should be 10. And one of the sides is 6 and the other is t. So it doesn't matter which of the two, either or. Doesn't matter which order you add those 2 squares together. But what that gives us is t squared plus 6 squared is 10 squared. Now, if you prefer to not have the squares, we can work those values out. And then we are undoing like we normally would when we solve an equation. Undo the plus 36 by subtracting 36, and then undo the square by taking the square root. And so t equals a. And if you do it that way, you've only got one formula to ever remember. A squared plus b squared equals c squared. Any questions about that? So really all the questions we're going to do today pretty much rely on Pythagoras' theorem, rearranging if we're finding the shorter side, and when they're all mixed up you might have to find the hypotenuse. So you don't need to rearrange, or you don't need to solve when you're finding the hypotenuse. Whereas here we're solving for that variable on the left. Okay, so that one worked nicely. They don't always, as you know. If we look at the next one, putting in the rule, a squared plus b squared equals c squared, then we can write what we know. We know that one of the sides is going to be x, the other shorter side is 10, and then that's got to be 14 squared. You can choose to subtract 10 squared, or you can choose to work out what 10 squared is. And 14 squared, what's that? 96, yep. And then subtract the 196 from 100 from 196, so that just leaves us with 96. And then x is the square root of 96. which is not exact. So it's going to be 9 point something. I've actually got the calculator finally loaded onto my machine, so I can work that out. Well, that's a bit small. So 9.79 or 9.80 to 2 decimal places there. And I guess the other thing I've missed here is the units. Don't forget units. I haven't been a very good role model here. Adding units, please. All right, keep going. What's different about C? Yeah, they're in different units. So what would be the best thing to do here? Make them the same. And as long as we're consistent, it absolutely makes no difference. So we've got 14.9 centimetres, and perhaps we could change that to 25 centimetres first. That does sometimes trick people. So be careful, make sure the units are consistent before you do anything else. And then putting in what we know into the rule. So A is going to be the missing side, which is M, one of the short sides. We've got 14.9 and we've got 25 squared. And like I said, this line is optional. Get a bigger screenshot there. So 14 squared. Sorry, it's 14.9, isn't it? $222.01. So if we subtract that from 625, we get 402.99, and then we take the square root. So 20.07. Now, because we changed everything to centimetres, we must stick with centimetres there. Any questions about that? So really now, in a scenario, whether it's context or not, you should be able to use Pythagoras theorem to find either a short side or the hypotenuse, the longest side. Have a go at x. Now, we had a similar question to this in the previous lesson. X in this case is the short side though. So with this one, it's probably just as easy to write x here, in fact probably easier. And that height of that rectangle, it becomes the side length of that right triangle that I've highlighted there. I'm going to go over in green. And we should know, I think most people picked this up last time, that that side length there is 12. So x squared plus 12 squared must equal 18 squared. And 18 squared is? Thank you. So taking 124, we get 144, and then x will be the square root of 180. $13.42, thank you. All right, we will do harder ones than that coming up, a bit more challenging, where you've got more than kind of one shape or more than one triangle combined. But before we do that, a couple of little worded questions. So have a go. With these worded problems, if there's no diagram, you must draw one. You must always put the right angle in the diagram. All right, so previous question should have been pretty straightforward. Just drawing the ladder example. There's your diagram. There's your working. I just want to show you, I'll put that calculator back up on the screen. Just with that rounding, even though you can see here that second decimal place needs to be a 0, we will still write that as a 0 if we need to round to 2 decimal places. You don't omit it. So just bear that in mind. You don't just write 2.9 if the question says round to 2 decimal places. If it doesn't, then 2.9 is fine. But this one doesn't say that, but I just wanted to highlight it because it doesn't always come up, this 0 thing. And I like to highlight that when I see it, particularly in the early days. All right, let's keep going. One thing I've forgotten to mention with some of these questions is always do a quick scan to see if your answer makes sense. Always, if you're trying to find a short side, just make sure that your answer is shorter than the hypotenuse. If you're trying to find the hypotenuse, always make sure that that's longer than the other two sides. Just keep that in mind. All right, any questions about those? So in this next example, or these next few, it's a little bit trickier. So you can see there's 2 or 3 triangles combined in one, or slight variations. So I am just going to give you a little bit of time to have a go at those yourself, and then we'll go through any that people might like me to. When you are needing another side length to get a second side length, or what have you, always keep that answer exact, don't round it. So leave it as the square root of 125. It just gives you a more exact answer in the end. Although y is in this triangle, what's the problem with that triangle? It's not right angled, correct. So hence that 20 is actually not the hypotenuse of the y1520 triangle. However, it is the hypotenuse if we take this triangle here instead. And so rather than call that y, I don't know, I'll just call it d for the sake of something a bit different. And therefore we know that d squared plus 10 squared is equal to 20 squared, d squared plus 100, and so forth. And d squared is 300, so d is the square root of 300. So in order for us to find y, we need the square root of 300, that d value, subtract the square root of 125. So if you just keep those two answers exact, it just makes for a really nice final solution. Well, it might not work nicely, but it is as accurate as it can possibly be. We don't have to mess about with the rounding. Just be careful on how that looks on the calculator. You've got to step out of that square root sign and take the square root of 125. So there you have really good accuracy, 6.14. It may have come up to 6.14 to 2 decimal places anyway. There's no units here, so we don't have to worry. But in case it doesn't, you might get 6.13 or 6.15, so try and be as exact as you can. Now with x, because it is a particular side length we do want to find, we could then actually work that out so we can interpret it a little bit more. It's a lot easier to know about how long 11.18 is compared to the square root of 125. But always try and be exact. Try and keep this. Whoops, something's going wrong with this OneNote. Right, have a go at the next one. So x is the hypotenuse of that first triangle here. And so using c squared equals a squared plus b squared, that falls out quite nicely. We don't need to worry about any rearranging. Again, keep x exact. Now the beauty of that is in this question you can see I then have to go a squared plus b squared equals c squared. I'll put the rule up there. And then you've got the square root of 58 squared, which is just 58. And then 4 squared, and that equals c squared. So again, it's another hypotenuse actually that we're finding. So this 58 is the square root of 58 all squared. And that should make sense to you. When you square the square root, you get back what you originally had. Whereas had you rounded that, square root of 58 equals 7.62 is what people would round to. And then if you went 7.62 squared, you're not going to get exactly 58. And hence my point of trying to keep as accurate as possible. So that's a good one to show you how that accuracy actually works. All right, so just then finishing that off, 58 plus 16, so what's that, 74? This is so annoying. And now we can round that final answer. We'll see, actually I didn't, and I possibly should have, but it doesn't matter. Made this Y, not C. 58 is the square root of 58 squared. So that is this side length, which is the square root of 58, and then we need to square that side to use it to find Y.
Wait, how do you know that x equals 58 though?
It's the square root of 58. Well, we worked that out in the previous section of work. Yeah, so but when you square a square root, you get back to the original number. All right, so that's a little bit different. If you don't like that, you could get away with it by being as accurate, so kind of using where it says the square root of 58, writing that as 7.6157731. And you just try and then you write as many decimal places as you can and use that number. But the point is, don't round it too soon. All right, C is a bit different. How do people go with that one? So this time it's x that we need to determine, but we've got two of them. Both of those sides are the same. What type of triangle have we got here? It's a right angle triangle. It's not equilateral. We can't have an equilateral triangle. Isosceles, yeah. So you've got two side lengths the same. The process is no different to what we've done in the past, but we do need to use a little bit of algebra and like terms, yeah. So you've got x squared plus x squared. What's that equal to? Do not say x to the power of 4. No, because there's a plus in between there. 2x squared. We are adding like terms. X squared plus x squared, you've got 1x squared plus 1x squared makes 2x squared. And then that equals 18 squared. So 18 squared, I think we worked out last time, was 196. 320, no, 196.14, isn't it? 324. All right, what do we do now? Yeah, we have to divide by 2 first before we do anything else. So 324 divided by 2, 162. And then square root that answer. 12.73, yeah. Yeah, so now that's our final answer, so we can round that. So you always round your final answer, yeah, just so you can interpret a little bit better. Okay, a couple more just to finish off with. And then let's see if you can work out the puzzle. A prize for someone who works out the puzzle. No, that's not the puzzle. Puzzle's at the end. So the length of CB, so we've got this whole thing here. What's the problem with trying to get CB as a length in one hit? We have to figure out some information, and that CB is not on a right triangle. That angle is not 90 degrees.
Yeah, and D's in the way.
Well, if that was a 90-degree angle, regardless of what D was, it wouldn't matter, or where D was positioned. But because that's not 90 degrees, and we can't assume it is, unless it's got a little right angle symbol there, then we could. So we can't assume it's 90 degrees, and so we have to assume it's not. And therefore, you cannot get CB in one hit. We've got to split it up. So you might want to call one side x, I don't know what's going on with this, and one side y. So if we start with x, you should be able to finish that off now. So because we lost half our lesson today, can I ask please that you complete those couple of examples and perhaps try some of these. Maybe we'll go with some of those harder ones. So we'll start at 5 and just don't worry about 1 to 4. So just do from question 5 tonight for homework. So there's about 6 questions to do there. Okay? And if you can pick the puzzle, I'll give you a prize tomorrow.